So in 9.1, we used Pythagorean theorem to look for the sides of a right triangle. And today what we're going to do is focus on how we can write the ratio or the fraction relating the sides to each other. And so there's a little acronym called SOHCAHTOA, and that helps us figure out the sides that we can say are proportional. So the SOH stands for our sine. So sine is going to be O, which is opposite, over H, which is hypotenuse. And then we have the ca part, which is cosine, and cosine is going to be adjacent over hypotenuse. And then we have our last piece, which is the TOA, and the TOA is our tangent, which is opposite over adjacent. Now, each of those have a abbreviation. So sine is going to usually look like SIN, and we say it as sine, not sin. Cosine is COS, so we say cosine instead of cos. And tangent is TAN, and we're going to say tangent and not tan. All right, because you want to sound smart mathematically. So we're going to go sine, cosine, and tangent. And again, we're looking at the sides, and the sides are dependent on the triangle. And so something to keep in mind as we look at a right triangle is we usually will say that our angle, our right angle is going to be letter C, and across from it is little c. All right, and then and then A and B, we can call whatever. So I'm going to say this is angle A, and across from it is side A, which is going to be just a little letter. And then we've got, let's just do B, and across from it is side B, which is going to be little b. And I want to just talk about that because it's really important that you understand that the side across from the angle is always going to be the lowercase. All right, and we still might need to use Pythagorean theorem and all of those things that we already know, but that's a key piece. The other thing that we want to make sure that we remember is that across from cosine, across from the C or the right angle is always our hypotenuse. And we talked about that last time as well when we did Pythagorean theorem, that it was really important to understand that the right angle across from it is always hypotenuse. The other two sides didn't matter, but the one across from the right angle is always hypotenuse. And it's going to be the same case now when we have this right triangle. But the opposite and the adjacent changes based off of the angle that's given. So if I'm doing angle A, then across from it makes the opposite side. And that makes the other side be adjacent, if angle A is the one that's marked. All right, and so if I chose to do angle B, then what happens is hypotenuse still stays hypotenuse, but the angle B is going to change things. So if this is angle B, across from angle B is opposite, which makes the other side be adjacent. And it's just going to be dependent on what angle it tells you to use. And whether that is an A, B, or C, or whether it's like M, N, and P, it doesn't matter. But the idea is that whatever the angle that's marked, and that can be marked with a letter, it could be marked with an arc, it could be marked with a question mark, it could be marked with a Greek letter, theta, which like example 1. And that's the most common when we're using trig, is this little theta. But it's just a Greek letter. And all we're going to do is write down the ratios. It says 6, but we're just going to write down the 3 trig ratios. All right. So when I look at example 1, the key here is that I'm looking at my triangle, and all I'm looking for is where is my angle marked. And so this is the angle that's marked because it has a little theta mark in the corner. Okay. Notice that the other angle up top has nothing there. So across from the right angle is our opposite. Our hypotenuse. Let's think this through. Across from the right angle is the hypotenuse. Across from the angle given is opposite, which makes this piece be our adjacent. And when I'm doing that, all I'm doing is writing the ratio. So sine, remember, is opposite, because we're looking at SOHCAHTOA again, so I'm just going to rewrite this. SOHCAHTOA, so you can see it. So sine is O over H. So sine is going to be the opposite side over the hypotenuse, which is 17. And I just write down the fraction, and that's my answer. And the cosine is adjacent over hypotenuse. So I look at the adjacent, which is 15, and the hypotenuse, which is 17. And then our last one is tangent, which is O over A. So we're going to do opposite over adjacent. And that's all I do. That's my answer. So I just write it down. Sometimes they give you the ratio without a triangle, and you have to draw the triangle that goes with it. So if I have a triangle, and again, this is my right angle, so across from your right angle is always hypotenuse, you get to pick which angle you want to be marked as theta. Whether it's the bottom one or the top, it doesn't really matter. So if I say it's the top one, if this is my theta mark, then this is my opposite, and it makes this my adjacent. All right. If I would have marked the angle down here, then opposite and adjacent switches if I would have marked the other angle. But now we have to think about this. So if the sine is 9 over 13, that means this is the opposite length, and this is the hypotenuse length. So that means opposite is 9, so the value here is going to be 9, and the hypotenuse is going to be 13, which means I don't have an adjacent side. And you guys can't write the ratio without all of them, right? Sine, we already know. We know that sine is going to be 9 over 13 because it's given to us. All right, but we can't find cosine or tangent without knowing what the adjacent length is. And so to find the adjacent length, we're just going to do Pythagorean theorem. So remember, that's a squared plus b squared equals c squared. And so we're looking for the adjacent side. So I'm going to say a squared plus 9 squared is equal to 13 squared. And then remember, the way we solved it is we just subtract 9 squared from both sides. And so in our calculator, let's make this smaller. Oh, whoops. Let's make this smaller. Okay. So then from here, all we're going to do is figure out what that is. And so we're going to go 13 squared minus 9 squared. And notice we get 88. And 88 is not a nice number. Like, it's not, like if I take the square root of it, it doesn't come out as a whole number. And so what we're going to do then is we're going to take the square root, and we're just going to leave it as a is equal to the square root of 88. All right, and so this is going to be the square root of 88. And so now when I go to do the cosine, you can simplify this square root of 88. So we can say, oh, well, it goes into it. So this is 2 and 44. This is 2 and 22. This is 2 and 11. And so we have a pair of 2's. We could do that and say this is 2 root 22. I'm not exactly sure what the computer is going to want you to do. Realize you could do either. So when I do cosine is adjacent. So we're going to do square root of 88 over our hypotenuse, which is 13. Or we could have gone 2 root 22 over our hypotenuse, which is 13. I was going to do that in pink for cosine. Okay, so again, cosine is adjacent over hypotenuse, or we could write it as 2 root 22 over 13. Either one. And then our last one is tangent, and tangent is opposite over adjacent. And we can either write it like this, or we could write it as 9 over 2 root 22. I think it will take either. I'm not positive, but I think it will take either. All right. So that's if we're given a ratio, we have to draw the triangle that matches it. As we look at example 3, same idea. Notice that I'm missing the hypotenuse value. So I have to solve that before I can do anything. So we're missing the hypotenuse C. And so we're going to do a squared plus b squared is equal to c squared. So it doesn't matter which one is a and which one's b. So I'm going to go 10 squared plus 20 squared is equal to c squared. So this is 100 plus 400 is equal to c squared. And so this is 500. And then again, 500 is not a nice perfect square. So when I take the square root of each of them, then I can either break it down and say, okay, well, this would be 5 times 100, and this is 10 times 10. So you have a pair of 10s. So you could say that c is equal to 10 root 5, which is probably going to be the easiest answer. Or you could just leave it as root 500. And I'm not exactly sure what your computer is going to want you to do. So when I go to do sine, again, if this is my angle, okay, so we always want to make sure that we label our angles, label our sides very first thing. So across from the angle that's marked is opposite. Across from the right angle is hypotenuse. The other side is adjacent. So when I go to do sine, remember sine is opposite over hypotenuse. And whether we write this as 10 root 5, that's probably the best way. And so that our 10s are going to reduce, and so we're going to get 1 over root 5. And then cosine is going to be adjacent over hypotenuse. And again, 10 goes into both of them, so I get 2 over root 5. And then our last one is going to be tangent, which is opposite, which is 10, over adjacent, which is 20, which reduces down to be 1/2. And we just want to make sure that we always reduce, like that's one thing. I don't necessarily have to do anything with the radical, but you always want to simplify as much as you can. So when I look at example 4, our first step again is to figure out what we're missing. So we draw our triangle, and you guys can draw your triangle however you want. You can do it with your right angle up in the air if you want to, or you can just draw your normal right triangle. But if this is our right triangle, remember this is hypotenuse because it's across from your right angle. And then you have to determine which angle you want to mark, whether it's the angle up top or the angle on the bottom, it doesn't matter. So if I do it the angle on the bottom, then this is your opposite side, and this is our adjacent side. And what we want to realize or understand is that cosine is adjacent over hypotenuse, so that I can put those values in the right spot. So adjacent is over here, so this is going to be 15, and hypotenuse is 17. And so that means that I'm solving, I have to do trig. I have to do Pythagorean theorem to find the missing piece. And so I'm going to have a squared plus b squared equals c squared. And so in this case, we're going to say we're missing, it doesn't really matter, a or b. So a squared plus 15 squared is equal to 17 squared. And then we're going to solve. So we're going to subtract 15 squared from each side. And then in our calculator, we're going to go 17 squared minus 15 squared. And we're going to get 64. And hopefully we know that that's a perfect square, so that when I take the square root of it, I'm going to get a is equal to 8. If you don't know that, you can put it in your calculator and see that it's 8, but that makes our opposite side be 8. And now we've got everything we need. So sine is opposite over hypotenuse, so that's going to be 8 over 17. Cosine is going to be adjacent, which is 15 over 17, which notice we already know that. That was what we were given. And then our tangent is going to be opposite over adjacent. And really that's all we're asked to do is just write our ratios. So a number over a number, always reduce it. Simplify your radical if you can't. So personally, I think that these are going to be your better answers if you have a radical. It might take the 9 over root 88. I'm not positive, but this would be a better answer than I mean, this is a more simplified answer, I should say. And same thing with example 3. I could have wrote those as root 500, but I'm pretty sure they're going to like the 10 root 5 better. So I think that these are going to be better answers. The computer might be nice and take either, but I think those are going to be your answers that they're going to want. Okay, the last thing they're going to ask you to do is calculate an actual sine of an angle measure, or an actual trig function of an angle measure. And so what you need to do, though, is make sure your calculator is in degree mode. That is huge. If it's not in degree mode, then you're going to run into problems. And with that, you guys are going to want to make sure, if you're using one of my calculators, you just want to make sure that it's in the right form, because if the batteries fall out, it resets it. If we have to change the batteries, it resets it. Sometimes people just mess around with the calculator and it resets. And so you just want to make sure that you do that. And the way you're going to do that, and we should always do this as our first step, especially if, once you do it on your calculator, unless you have to take the batteries out, it should stay in the mode that you want. But if you're using one of mine, it's always just good to check. So you're going to push mode, which is right here by the second key. So it just turned red. And then you want to make sure the degree is highlighted. So notice you've got this little degree as you go down. Like if radian is highlighted, so let me go down. So see how radian's dark and degree's not? You want to go to that function, go over to degree and push enter and make sure degree, it's black on the degree. And that tells you that it's in degree mode. And then once it's there, you go second mode to get out of there. And then we're just going to plug in our values. So when I look at sine of 9, I just put in sine of 9, close my parentheses, and I get 0.1564. And you're going to just do 4 place values. So this is going to give us 0.1564. If I do cosine of 37, same thing. I'm going to go cosine 37, close your parentheses, and we're going to get 0.7986. And then our last one is tangent of 48. So we're going to go tangent 48, close our parentheses, and we're going to get 1.1106. Okay, so we're just taking that 4 place values after the decimal. And that's if you're asked to find an exact angle measure. All right, if you have any questions, make sure you ask, and I will see you guys in class.